for our times. I'm Ali from Hong Kong office. So I'm the technical leaders of the transport and infrastructure team in Hong Kong. Our teams involved in feasibility study, constructions, design support, and also expert winners for various of infrastructures projects. Our teams always strive for innovations in delivering our professional service. So today I would like to take this opportunity to share with you our current explorations in measuring the surface deformation using InSAR applications. Considering some of you may or may not be familiar with InSAR, so I will spend some of the times introducing the InSAR. Later on, I will share with you some of the example in applications of InSAR, and then last but not least, I will share with you our Hong Kong current experience in using this technique. So InSAR, the last letter R actually is radar. So I think most of us are quite familiar with what is radar. Radar is a form from transmitters and receiver. Very often is used like to detect and then for using the measurements for rangings. So I think radar everyone is quite familiar with, and but the issue with radar is we often have the shallow effects where due to the geometry's problems many times we have a shallow effect that some of the buildings or object behind the high rise buildings, it get blocked. So we call it shallow effects. Also some we quite often encounter is the low resolutions. Subsequently, radar, there's improvements because synthetic apertures radars is where by considering multiple image taking along the orbit through portable, movable physical antennas, it actually resolve the shadow effects issues that we explained just now, and also it give a higher resolutions image. So we very often we use synthetic aperture radar, we call SAR, SAR, SAR image to create a 2D image or 3D reconstructions of objects. And what's InSAR? InSAR is the interferometric synthetic aperture radar we call InSAR. It's actually used two or more SAR image acquired at different times over the same regions to generate the maps of ground movement based on the difference of phase of wave. So from here you can see that there's two examples taken at different time intervals at the same regions. So the difference of it, we will then able to measures the deformations of these locations along two different times. So there's quite a lot fields available satellites nowadays, like say for synthetic from European Space Agency, also Teresa from Germans and Cosmos Italians, also Japan as well. So it depends on the user requirements and you select which satellite image that you apply to us. So it depends on the acquisition mode and also the data processing level. And most of the times we are using a level 1 processing level in InSAR. And as I mentioned just now, it depending on the user requirements. So here we summarize some of the examples of this. And let's say for synthetic and Terra, SAR, and Cosmos, most important is the resolutions. It depends on what kind of resolutions we are talking about, depending on the objects and the image, how large the size is, how accuracy is it. Let's say for Cosmos, 5 times 5 is 5 meters 1 pixel. So imagine that if the object that you measure is small, which able is already out of the range of these 5 meters. So resolution is one thing, and also the revisit time of this satellite, the image. Let's say for quite a rapid change of the ground, you might need to consider for more uh, close interval, let's say 7 days or 2 weeks. While for those that are quite stable, you might consider for months, let's say, or radar. So it depends on the change of the ground and also and related to the revisit times. Of course, related to the cost as well. So this cost is a new cost. Let's say we can go to the website, look at it, that there is a schedule. So we can pre-order for the image. And for those that pass image, there's a cheaper cost. So it all depends on the user requirement. So I thought that giving a brief introduction of the InSAR, now I will share with you some of the example of InSAR applications. So in the past, some of the researchers like Professor Ting in Hong Kong, Poly U, they compare the using the conventions InSAR by using the free image by the Sentinel European agencies. They compare with the published data in Hong Kong airport in 1996. to 1999. So it's so far their comparison using the conventional InSAR give us a very good result. 3.5 means of difference in compare of the InSAR process measurements compared to the leveling measures. And there's another group of researchers also compare later on is more, they call it advanced InSAR. They're using a persistent scatter interferometric PSI. So this is a InSAR development. From conventional InSAR technique, subsequently the researcher is keep improving it. And for this, they compare with the published measurements data in 2006. Unfortunately, because of the limited length of the time series data and other factors, it seems that in this study, the PSI is not well matching with the field measurements data. Well, subsequent improving also in 2008, there's using advanced InSAR also with filtering. You can see that all the data, the presentation is more smoothened. So this is because they adopt this filtering. So it's another improvement development of InSAR techniques. And unfortunately for this, there's no field measurement for comparisons. And then InSAR also used in some Macau reclaim lens. We know that Macau is a reclaim lens. Then it compare with the control point measurements. But because this ground has been reclaimed sometimes, so the settlement is quite stable. And so far, they compare with the yearly measurements. The InSAR, advanced InSAR technique with the field measurements, the accuracy is quite good, like 2 to 3 millimeters difference. And also in Shanghai Pudong International Airports, they're using a advanced InSAR modified PSI. So it's quite known that because for runway, because of the pavement, the runway taxiway compared to the landscape, there will be a row coherent in between two. But the researcher able to using this modified PSI, so far the result between the InSAR and the field measurements, the leveling is quite consistent as well. And also Shanghai City is a non-sinking ground because due to the difference of the groundwater level, it's always a dewatering issue. So the ground, the Shanghai City is keep settling. And using this InSAR technique, actually you can see that the whole of the ground area, although some of the building get broke, but in general, we're able to provide a ground measurements of this. So if compared to the measurement rate is quite consistent as well in terms of yearly. So this is some of the literature reviews that you're able in the publications. So today I'll take this opportunity to share with you some of our experience in Hong Kong office. So this is the project is newly reclaimed land at the westerns of Hong Kong. So WSP Golder act as a instrumentations and monitoring consultants to evaluate the reclamation's performance. It's just a newly reclaimed, so anticipate there will be ongoing settlements and also a future development. So this site is huge, 600 hectares we are talking about. So even just monitoring points is is more than thousands of numbers. So imagine that the labels, the info, and moreover, because this is a reclaimed lands, we need to develop for future development, saying constructing the tunnel, constructing the building. So it's an ongoing, quite active constructions. So there will be a difficulties in all these constructions contract interface, and also because of the ongoing excavation works and the developments of the constructions of the buildings and tunnels. So it's very difficult for the workers, for the instrumentation engineers to access the instruments and take the readings because of this ongoing infrastructure construction work. And also the locations of the instruments, it may clash with the temporary or even the permanent structure to be built on. So as the clients instrumentation and monitoring consultants, we propose an alternate way to this conventional traditional survey method. So what we do is we propose a TCP InSAR to the clients, and we are in close collaborations with the Hong Kong PolyU Professor Ting's group and also Ascension Unispace Dr. Chang. And with their teams, Professor Tings, they have been in the last 2 decades, they have been developing the InSAR. So we are adopting the TCP InSAR, the latest technology in this InSAR for our measurements. The reason of it is because TCP InSAR we call temporary coherent point InSAR. So the essence of this technique is actually using this multi-master correlation strategy. In the past of the conventional InSAR, it's always only single master. But imagine that because of this ground is a rapid change. Like this month is still a static ground, but a month later we will have excavations of 3 months later or half year later, we have a tunnel built out. So considering that it cannot retract back to the first single master. So we use this technique multi-master. It whereas that it have its own correlations, and at certain stage we can use at the intermediate master image as a master. So we eliminate the single master issues. So we also use ambiguous coherence estimator, adaptive filter. This is the latest technology for which we considering for this ground conditions application is more suitable. That's why we adopt TCP in INSAR. And then we are using Italian satellites Cosmos with the resolutions of 3 meters times 3 meter for 1 pixel. So there's a 1 to 5 meters. We adopt 3 meters for our site because considering our site is 600 hectares, which is quite huge. And our accuracy we are considering for 3-meter X-band. And for satellite image, because it is 100 kilometers for one image, so it cover a large area, but we focus in our interested area. So we're looking at bi-weekly, 14 days of time interval. So I think bear in mind that we want to share with our challenges. Although we pre-order from the satellite agency, the image that we're looking for, but we encounter some of the challenges where that sometimes the satellites, due to the maintenance, they or rearrange the route, they'll just cancel the image. So end up the interval at first we plan for 14 days, sometimes it could be up to 1 month. So for this, just now I mentioned conventional, we using a single point or a single master, but for here, because we're using a multi-master correlations, so for whatever images we pair out, say 6 or 7 images pair, we managed to find the masters at certain period. So although we have, let's say 12 images, the master coherent at the 6th or at the 7th, it could be developed as another master. So we no need always refer to the original, the base case from day one. So this able for us to capture what happened in between of the developments. So we also adopt a adaptive filter, considering that because this is near to the sea, there will be this atmosphere's effects, and because of the refractions. So this technique we use adaptive filters for higher value, mean value for lower resolution. So it's kind of like improvements of the techniques for data processing part of it. And also we have this coherence estimators from here that in the past we may not know that how coherent is between the pair of the image, like how coherent points we can find. So let's say for the one coherent one is the perfect, which means that the points is able to detect in every of the image. But unfortunately, as I mentioned, that because the ground is under development, so let's say for a stable grounds, that coherent is always consistent. But those for the development grounds that where we have subsequent constructions or buildings, the coherence is lower. So it depending on the user what we need. If we're looking for a higher accuracy of the data, we can set the coherence is higher, but which means that we have a lesser data. And if we require more data, but bear in mind the accuracy will be lower. So this technique allows us to adjust whatever the user is looking for, whether it's qualitative or quantitative. And go through the process of flow chart. I'm not going through today's because this is a long, it's a detailed process, a very detailed process. But I want to share with you that because as a user, as engineers, what we encounter the challenge is we found that what I shared just now is the acquisitions, the SAR image. So have to plan. If it's a very rapid change or development, we have to plan that to acquire the image with a close intervals, 7 days, 14 days, or months. If it's a stable ground, it's just like to monitor ground settlements long terms. and then it can be a month or it can be a year. So images acquisitions well planned, and also depending on what kind of restorations, and also expand depending is a ground or is a vegetations also depend. And also we found that as part of it, the calibration is quite important because the reference point, all this we have to set and calibrate with a survey menu as a reference point. So bear in mind that a conventional reference point is just a single point. But just now I mentioned that because of the accuracy, the restorations, imagine that the pixel is 3 meter by 3 meter, but your control point is only a single point like 10 cm, which means that it's not able to detect. So make sure that the reference point, the control points as a calibrations, as a base case, the datum has to be rigid enough. It could be considered, we are trying to explore using a building on foundation, which is a stable building, take it as a reference and quality. Also, for the whole process, also the surface deformation accuracy very much relies on the ground. So bear in mind that if the ground is settling, please do not take it as a reference. You should refer to whatever is stable it is. So from our project, we able to work with the menu survey. We do the calibrations, and then we work it out, and some of the parameters, because we near to the sea, that's where atmospheric, the atmosphere, the moisture also affect, and because runway landscapes, and because of the pavement and other things, we all this need to be calibrated, and we compare against with the field measurements for more convincing and promising data. So we managed to work with it, and we want to share with you some of the pros and cons when using the InSAR. So the pro, definitely the advantage is non-invasive monitoring. It require no site interventions and no need maintenance, and is high resolutions of surface informations. You can measure the ground, you can measure the structure as well. So like for our case here, we are talking about 600 hectares of area, large area of monitoring. Definitely, this is much more cost effective compared to any of the conventional methods, and is flexible in monitoring frequency. For rapid change or for constant ground area, it could be monthly or yearly, that kind of monitoring. So it depending on the project requirements and monitoring purpose. So the cost definitely will be can adjust, because if it's yearly, we only need two image per year, is low cost. So against labor efforts is low. But the cons, the disadvantages we want to share is highlight that the reliable on the stable for reference point is very important. And of course, for our stable modern city with like New York City or what else, is less change in the city, but not for rapid development of the cities that you need a very stable reference ground, reference point without any change. And then bear in mind that this require very high demanding on the computationals, and it has to be built, because some of the commercial software, it can tell us that they're able to measure all these things. But again, I would advise, based on our experience last 2 years, the field measurement comparisons and calibration is very important, because the uh, back analyzing or curve fittings, saying that the accuracy could be 2 to 3 millimeter, but based on experience that for predictions and also for the trends, it has to be compared with the manual field measurements. So InSAR together with a manual survey as a whole package, rather than InSAR stand itself. So it has to be uh, compare and calibrate with the manual survey. But definitely, because it share the information between the manual survey, it provide us more information and supplements the missing part. And especially for those area that we are not able to hit, let's say for the hill area, then it will be very good. So other application of InSAR, not just for reclaim land that we shared just now, it's also useful for landslide monitoring, or for the slope stability as well. And some in China, they use for vegetation growth monitoring as well. So for even for our tunneling work, because of the ground settle due to tunneling work, it can be used like Sydney, or can be used to monitor the ground deformation due to tunneling work as well. So I would say that this technique is very useful, and based on one image for 100 kilometers, it can be used to monitor or different infrastructures and development within that 100 kilometers. So myself definitely very recommend for this technique to be widely used in futures and current. So that's all for my presentations. And feel free for any questions from the floor. And if not, you can drop me emails and feel free to share. I will willing to share with you. I'm sorry that we cannot share much on our project because it's under development, and hope that in future we will publish more paper. Then you can learn from our experience in last 2 years that how we tackle with the large monitoring area, and also how we use this technique in comparison to the conventionals and other remote sensing. So that's all for my presentation today. Thank you very much.
Thank you, Ailey, for your presentation. Fantastic presentation. So now it's the Q&A time. Please continue to log your questions in the question box on the control panel. I will start with the first question. What is the precision and accuracy of measurements between InSAR surveys?
Based on my experience, also some of the published paper, the accuracy can up to 2 to 3 mm. So, but it again, I would like to emphasize that it depends on the satellite image that we select, because I explained just now, some of the resolutions is like 1 to 1 meters or 5 meters, and also the interval. And then it's really depending on the ground conditions, because let's say for my case, because the ground is rapid change, and then even like we go for 3 meter by 3 meters at in certain rapid change condition, we're not able to capture it as well. But for a stable ground, we're able to compare with the manual survey. We can reach up to less than 5 millimeter. So bear in mind that although some of the people or research tell you that it's less than 5 millimeter, but bear in mind, you have to case by case, not apply. It's not a universal rule. You have to be case by case. Yep.
Thank you. Is InSAR applicable for progressive landslides?
Yes, but I would say that because it depends. You need to, if you foresee that you will be a progressive, and it very much on kind of like the time interval, because as I mentioned just now, that satellite image, because they will capture the image for the ones that Cosmos we're taking, is the interval is 14 days. So if the landslide happen 2 to 3 days, you miss out the interval, you're not able to capture it. You probably capture after post. So if you want to really rapid change ground, your time interval for the satellite images have to be a very close one. Well, some of it they mourn for kind of like yearly. It's just a yearly events or other things. The interval will be longer. So if you think that your site is a rapid change, then you may consider to purchase to order the images with a close interval, so you're able to capture the change in between these two images. Yeah.
Thank you. What is the recommended frequency of the manual survey? Is it ongoing throughout the project?
For manual surveys, if we have the InSAR as a supplement to the manual survey, I would say that the manual survey is just for the calibrations and the comparison. So the interval, the frequency can be reduced because it's a labor intensive. But although it gives a very high accuracy with the reference conventional way, but it require labor intensive. And also sometimes we have a access problem as well, because sometimes we hand over the construction site or we hand over the development site to other party. If we go in the site to take the survey, to take the reading, I think this is quite often we have this issue. So with InSAR, we able to resolve this issue. But then, as I mentioned, I highlight it has to be calibrated with the manual survey. So with this InSAR, if we say that the InSAR give a monthly readings, if it's a stable ground, you don't foresee is keep settling or keep a change of development, I would say that if for the InSAR is monthly, and then the manual survey could be once in 3 months times, or what. Yeah, so it's a less interval to do the calibration.
Thank you. We have a question here from Sweden. In Sweden, we have used InSAR for 7 years now. We do share your experience that InSAR is a really effective tool in urban areas. The question is, do you have any experience using L-band satellites like ELOS?
Not yet. So in my case here, we use a Cosmos, so we not yet explore the L-band satellite. So here is we are using an X-band. Yeah. So we hope to contact with you in Switzerland to share with your experience in using this L-band satellite, because I think with our poly use the advisors, because we are using our dealing with pavements and also some of the landscape. So advice is using X-band. That's why we goes for Cosmos, and also because of the satellite frequency. We are now at 7 to 14 days. That's why in our case here we use Cosmos. I'm sorry that we not yet explore the L-band. Hopefully one day we can share experience.
Yes, of course. Thank you. The next question is, can InSAR be used to monitor long-term settlement at a facility?
Uh, Yes, I think, but it depends on what kind of facilities you are referring to. Bear in mind that if it's a window, there's a refractions. So very much that, because bear in mind that this is kind of a radar, is a wave. So let's say for water is not working on, so it's a window or is a concrete or is a different. And also bear in mind that if your building is higher than the ground, and then some of the thermal effects is affecting the wave, so it has to work with calibration of the manual survey, and then some of the just now some of the factors that I mentioned just now, it could be eliminated with a calibration, and then later on we can use it for our long-term monitoring. So yes, we can use it, but we need to do a proper calibrations. Then we only can able to for our long-term monitoring.
Thank you. Just to do the time, I will take the last question. For monitoring of large open pit slope stability, can InSAR be recommended?
Yes, I think for this large open pit or large scale project, because I think the challenge of our conventional or even a remote sensing is just a single point. So we're not able to really know, especially for slope. Sometimes as engineers, we have a limited monitoring point, and somehow we need to make a decisions whether at the middle of the slope or top of the slope or bottom of the slope. So for through this technique, and also even I think our team previously we explore photogrammetry. So photogrammetry and InSAR, we able to do the monitoring for this large scale of the slope or even mining. But again, bear in mind, I think is very much on the frequency. Let's say for the photogrammetry through drone, and then with the calibrations of the manual surveys, the drone we can fly quite frequently. Well, for satellites, it really because the interval is like 14 days and 7 days, is also the cost is high if compared with photogrammetry. So unless you're talking about large scale, because the satellite image we're talking about 100 kilometer. So if your ground, your site is greater than kilometer or what else, is it will be good, because using a drone, uh, I think is compared with the cost and the requirement of frequency. But definitely these two technique I will recommend, photogrammetry and InSAR.
Fantastic. Thank you, Ailey, for a fantastic presentation. Thank you, everyone, for joining us today. Please feel free to follow up directly with Ailey via the contact details shown on the screen. And again, thank you for this nice Snackathon series. This is the last webinar in this 2022 series. We had over 60 webinars this year, and we hope you enjoyed them all. So we look forward to sharing with you the upcoming schedule for 2023. We'll have amazing topics again. So thanks again for your support and joining us in these webinars. Thank you, Ailey.
Thank you, Sharon. Thank you,
Thank
Sky. Thank you very much. Goodbye.